I think there is something of a tradition of collapse here. Sporadic collapse, or sporadic collapse and then reassembly. I think the first exhibition we did with Nader and Monica, when they had rope, which Raymond thinks is a tensile material, but is actually a compressive material, therefore it fell down. But they put it back up and used the glue to make the rope work, more or less. And then Greg Lynn made a project which you recall collapsed, which was propped up with a couple of twigs. And now Alexis joins the parade. Greg and Alexis of a project which is, as they say in Argentina, no está. So
that means it's not here. Translation.
I think so. But it's in your head, which is probably what counts. Or maybe the project is really the joint, in which case. Huh? So
that's
what I think it's been constructed twice. They've been collapsed twice. So it's probably worth considering the implications of collapse and whether the aspirations of the jury of the gallery, of the SCI-Arc, are confirmed by at least once in a while the project collapsing, which conceivably is indicative of a process where one doesn't know the conclusion and anticipates a conclusion, and we arrive at something a little bit different, which conceivably has something to do with the process of learning, at least in an ideal sense. I assume if everything collapsed, and if everything we did fell down, then that would be suggestive of a slightly different problem, of a kind of intrinsic incapacity. But if once in a while it happens, so maybe this is a good sign. By the way, I wanted to mention, and I think some of you know this, there is a text of the gallery, a large book that runs, I think it starts with Monica and Nader, and it runs about 7 years of exhibitions, and it concludes with Alexis. Means the pages are likely to be blank, and the ubiquitous, Bruce, is Chinese? Bruce Lund, the inheritor of Fiden, Rizzoli, Thames and Hudson, and so on and so on, is publishing the book now for the gallery. It's an enormous book, and I think a special book. And he's agreed to do that. So now they'll conclude with a few blank pages. So this is, and that should be out, I don't know, in probably 3-4 months as soon as we can pull the last couple sections together. So this is something to look forward to, and I think it's a useful document to the school. Alexis apparently claims to have assembled this project and it disappeared. And he'll demonstrate the aforementioned condition, I guess, by putting up a few images or narrating a few. You want to?
Yeah, we'll do as mean of introduction. Oh, thanks to everybody for coming. Thanks to the team for having been twice around the globe with the Octa.Bot.
Your team?
And
it's 50 guys.
It is a little unusual because usually you have like the piece kind of speaking to itself. We're going to have a little bit of an introduction. Bear with us, this is like about 4 minutes long. It documents a little bit the project from the very get-go. We're not going to show the previous iteration, hopefully you guys saw that. But over here we're going to talk about the joint that is a project we've been developing for the last 2 years. The basic joint or the principle that we set up for ourselves is kind of that drawn out mobility within the joints in such a way that we can create rigid frames without having to cut compound angles in structural configuration. Specifically, we've been looking at the space frame as a way of kind of testing our ideas. So that's in a way the basis for the exploration, and it has to do with, I think there was a very interesting distinction out of this process that kind of has to do with the difference between fail and collapse. I would say that the thing didn't fail, it rather it collapsed. I mean, at some point it actually kind of came together, and it came together for an hour, a full hour, which is an hour more than just drawing. Yes. So we just, you know, it was
starting to sound like a political campaign. Failure and collapse.
So let's look. Now we're looking at the assembly process. The whole project is like 400 and something struts, about 1,000 different angles. Nobody really talks about angles. They talk about the relationship between the elements, and it took about 12 hours to assemble. So in a way that talks a little bit about what the joint does and how it does it. So here you can see some of the pre-assembled elements. We have the configuration itself is about, it's an 85-foot bent truss that kind of loops around and delivers 20 feet in any one direction and spans 20 feet across. So that's a little bit of what we're looking at. The weight of the whole piece is about 350 pounds. And all those 350 pounds are going into that one screw. So not into the joint, into that one screw. The first project that we did, which is the one that we had last week, it was mistaken for monkey bars for a few times. So the thing actually did work, but it didn't support 3 people hanging from it and taking the shirts off and so on. So that was a different problem altogether. This is just a reckless
He's making that up.
True, and that's why I like reality and building stuff. Reality is always more powerful and surprising. Depends on what reality you work on. So here now you can see kind of a little bit in more detail kind of how the connection process works between joints. The interesting thing about, at some point I think we're going to set up a series of drawings in the wall and showing what level of documentation we used to put these projects together. Yeah, it was, but I mean, in a way, just like that's what we wanted to. I mean, I think that one student came and he looked at it and he said like, it was overly ambitious. No problem with that. I mean, if this thing wouldn't be able to take it, I mean, I always imagine what if it actually stands and it did for about an hour, but I don't know if you saw in the back when we do the playback, the actual reflection of the beam. So we're going to capture the weight. So this thing, in this case, the whole cantilever reflected about 6 inches from the get-go. And in each iteration, we actually try to work with different support types. In this one, last time we had a series of actors in the ground and on the top beam. For this case, we actually wanted to test the walls as a support. Instead of supporting from the ground, we actually wanted to support the same from the body. So here you can see a little bit of the deflection of the piece and how the joints are being not tightened, but kind of swivel or put into place as we actually let the thing go down. So if any one of the joints actually wants to rotate, you actually, by going slowly, loading the structure slowly, we're able to adjust it into place in such a way that we have a smoother load transfer.
So this piece was always secured from the
What's that?
This piece was always secured from the beginning. See how one sort of survived.
That's right. What you see on the wall is the foundations for that project. This is a little bit the final completed project. "16 minutes. Now you can get a little bit of CIA footage.
It's the latest.
Which actually, was very interesting to have this material because it actually allowed me to figure out that it's not the joint that failed, it was just reckless engineering from our part in terms of not having a stronger connection down at the bottom. So that was a pretty revealing element. The other interesting thing is just like this is, when we set up to get this project started, we had to make a certain concessions in terms of we were interested in kind of the capacity of the joint to resolve geometrical problems, and we could resort. I mean, the only way we could do it was like to actually use a nylon joint. So we had like about 12,000 psi of tensile strength on the joint itself. So that kind of gave a little bit materially, gave a little bit of a constraint on kind of how far you can go in terms of the situation.
So why don't we, in the public relations session, we talk a little bit about what the project means. One of the aspects of these projects in a pedagogical sense that we've discussed, as a lot of you know, has to do with the antecedents, the conceptual antecedents over a long period of time that belong to this sort of ideas. So the notion that this is, that it came from nothing, or that it's strictly in a conceptual way novel, is not accurate. And it needn't be. So you have people like John Bouvet and Marcel Lodes. There was a project, I think, in the 1970s done by Kendall Tange's office at the ball joints that I think Isosake designed. So there's a conceptual issue and a tradition over the last 100 years or so that deals with this subject. So the first question would be how this fits into that discourse, meaning is it a simple adjustment? Is it a contradiction? What is it? What do we know? What have we learned from this invention? How does it respond to what preceded it? And what does it forecast in terms of what it can do and what it can't do? How does it belong to a line of history? And how does it move the history forward if it does that?
Also to mention Conrad Boxman, they're actually going to have like a huge investigation and enrich the field. Let me start up. I mean, I've been particularly interested in the space frame as a technology. It's actually an invention by Alexander Graham Bell from 1903. So these guys came up with like a system, and they were trying to use it for aeronautical purposes. It wasn't even for architectural purposes or engineering ones. The interesting thing about it, I mean, like as people started studying kind of the space frame as a possibility, they realized that it was an incredibly versatile system. And however, most of its difficulty relied on the assembly process. So most of the, for example, you can span like 150 feet, 200 feet, no problem with the space frame. The problem is like you always have to have like this regular joint. You can have like double curvatures if you want, or change the direction theoretically. However, the complexity of having to assemble, let's say, a parabolic shape out of the space frame technology, it kind of renders the system kind of pretty much not useless, but incredibly complicated. So what the idea behind the project was like, how we can actually incorporate the other structural elements or types of geometry within, without having to kind of like go through the intense fabrication process of having to cut every single one angle. We have like compound angles in every single one of the nodes of the joints of the space.
But as a premise, what's the project? Is the project the joint, or is the project project what you make having produced the joint?
The project itself is the joint, and that's why we don't change configurations because I think collapse. We actually change configurations because we want to show the versatility of the project. So it's not so much like a formal hangout that has to be this form specifically. We're actually interested in exploring the range of possibilities that you can achieve with the joint itself. So most of the work is kind of developed on the joint. You know, one of the things that we want to do is actually the next configuration is sort of like a hand over to the team that actually work on the thing, so the design and the putting together process, it kind of happens no longer from the architect itself, that, you know, in terms of the one that designs the assemblies and so on, but actually other people take over the system and it will be interesting to see kind of what comes out of it.
But if the issue is to make a joint and demonstrate the versatility of the joint vis-a-vis other systems which produce conventional kinds of space frames, then in order to see that manifest, you would have to see it in the room. You would have to see what it can do that other pieces that are analogs can't do. So what can it do that other pieces can't do?
One of the things is also the assembly time. I mean, like, we're like a stable team of like 6 people, and we put one of these projects together in 12 hours. Meaning the reduction of time and mass within the structure itself is something that we're
But then when you're talking about it, time is an issue, and we're talking about something that goes up and comes down. So we're not talking about something which is durable in a conventional architectural sense. It's not going to sit there for 1,000 years. It's going to sit there for 2 weeks.
It could.
So it's an installation mechanism.
It could at this stage. I mean, like, the idea is to actually kind of continue to evolve the joint and the idea of the joint into something where you can actually achieve like permanent structures. I don't want to kind of circumscribe it. I mean, like, that's why I said, like, we're trying to test a geometrical principle, and then out of that kind of continue to develop the joint, learn from what, you know, the design flaws that we have, you know, within the joint, kind of correct those in such a way that we can evolve the system to kind of achieve, you know, if there are permanent structures are.
Let me turn it around in a different way. One of the discussions that we've had, I think, over time is that architecture not only requires colleagues and friends, but it needs enemies. It needs oppositions. And I think a lot of the contemporary discourse in architecture has to do with a sort of congeniality quotient, and everyone is friend and no opposition. There's nothing you won't do or can't do or will refuse to do, and almost anything in a certain way is possible. So to look at it in a different way, this really doesn't belong to conceptually a digital representational mechanism, when the criticisms are also that the process of implementing what's being drawn is not understood. So maybe this is a leading question. Who's the enemy? What's the enemy in this context? Or what in the discourse does this say to people who do something and you say don't do something different? Or when you start the process, you understand first how to put the pieces together. And then secondly, you understand how the pieces will be put together. So in a certain way, the assembly mechanism precedes the specific content of the project, as opposed to the other way around. You make something, and having drawn it, you send it to somebody and say, please make it stand up.
The enemy here is 41 degrees, which is like the one we couldn't achieve. We kind of allow this thing to actually rotate all the way to 40 degrees. Believe me, I wanted 45, because like that kind of gives you even kind of like more versatility in what the system can do. But we could only achieve 40 after like 2 months of like that.
Guys, this is really not a scientific problem.
Huh? Well, we're getting to what
No, it's not. Space frame, it doesn't just be an order. That's easy.
Yeah, but there's another 150 people in the room, so you have to.
Yeah, you can make them stand up, Eric, come on, that's not the issue. That is not the issue to make it stand up.
Well,
What
what's
the issue is not really, I mean, because he did mention, for example, Bucky-Fuller, that's the most obvious affinity when you look at space frames out there. But Bucky-Fuller was so limited by making crystals, which are impenetrable. I remember in Montreal when the American Pavilion, when they made a hole in the dome for the membrane they went through. They put one of the most crucial architectural sacrileges ever committed. Or in the dome as a house, we made the fucking door in there. No? And this, what this does, the creature, the structural creature, can make magic things. And it's not so
but
much.
you need to give the architect room to define what he wants to define. Then we can backbench the thing. I agree with you, but it's for us useful, since it's his project, to give him an opportunity to tell us the issue is 45 degrees. I don't think that's the issue. I think what it allows you to do is to make out of a system which is a predictable system, and a kind of system where a space frame is no longer a space frame defined in a traditional way. Means the conceptual model of a space frame is now defined differently, which means the issue really, what the project is really about, is of course and always was, is what the joint allows you to do. And then the question is whether the architect actually invented the joint to turn it over to someone else who will demonstrate the capacity of the joint to make things, or whether part of the process is to confirm that it actually can make all sorts of things that space frames couldn't make. And there are a lot of issues that are the Tange and Sasage frame that I was talking about. Do you remember the one with the ball? And the elements that were attached to the ball were threaded. Yeah, so you threaded, but the pieces, each piece had to carry a different loading capacity, some at the top, some on the side, and so on. But to attach them, they had to be systematized, otherwise it's so difficult to put all of the pieces together. And in a sense, what you do is you design everything for the worst case. So most of the pieces are too big, most of the pieces are too heavy. So you have a kind of juxtaposition of assembly problem versus a kind of logic of structure where all the pieces would be different size and it's a pain in the neck to put it together.
The difference between the space frame and that is, in the space frame, the frame dominates, and the joints were made to hold it up. In this case, as far as I see it, I see that as points of constellation. You can mark those in space and then connect them. But it's not this.
What's odd about the this may or may not be so. Alexis should say, which means that underneath all of the structural conceptual logic is actually a kind of poetic sensibility. And a poetic sensibility has to do with the appearance, the aesthetic of the joint itself, what it looks like.
One interesting thing to touch on the idea of constellation, which is a good one, is like after developing the process and the molds, actually the molds for the joints were the most expensive part of it. So by the end of this process, all we could afford was 125 complete joints. So in bed, I mean, that's why we never designed the process, the project, until we kind of like go to like the final count of points. So the problem, the architectural problem for us was like how to define something with 125 points. So it wasn't necessarily kind of like any one form that we had to know and choose. Actually, what can we do with those 125 points as means of delineating architecture? And that was the first stage. In the second stage of the project, actually, we had the same constraint, but now the other constraint that we use the same elements of the previous struts, and we cut them all to lengths. So we are like still 125 points with the same struts, but they have to be shorter than the previous project. So just like that was a little bit of the logic of how how to.
But the response, it seems to me the response to the discussion about who the enemy is has in the end to do with the limits of the capacity of a conventional space frame, what it does and how it appears. And what you're really saying is that there's a sort of versatility in this that a priori models don't have.
Well, that's, I mean, the same thing, instead of having to perforate the sphere, one thing that we're interested in is like trying to negotiate the transitions between vertical elements and horizontal elements. In a way, try to override the idea of the hierarchy between structure and enclosure by actually having a uniform system that they can work the two problems at once.
I mean, let's try to get at it another way. An engineered project, Pompidou, space frame, is an argument in architecture in a certain way. And if you look at an oil rig in the North Sea, which is supposed to be Spartan and technical, and it is what it is as a consequence of the fact that it does what it does. And this is an old ideological pro forma which could ipso facto justify the design of a building and make it a radical building because it uses technique and technology to justify what it is. I'm not saying that is that or that's so, but it's a pretty conventional argument. It doesn't matter whether the technology is digital or whether it precedes that. But North Sea oil rig is an interesting model as something to admire. I mean, the Pompidou belongs to that an analog of industry and technique. It seems to me what happens here is that the argument is that the image of engineering doesn't appear here the way it conventionally would. And that how you recognize successful technique and technology is adjusted here if it isn't entirely modified, because you can make things with a technique that heretofore engineering didn't allow you to do. And you can look at the oil rig and you can see this is this big and this high and this deep and the waves do this and so on and so on, and the pieces that are made to overcome those obstacles in a technical way. And it's not so clear what this is overcoming, actually, which is why I said you don't really know what the adversary is. In other words, it allows you to invent, it allows you to make things in a way which belong to arguments which in the end aren't technical arguments. And therefore, it's not sitting in a technical argument, even though it seems to be about a certain technique. It seems to me the long-running conventional argument about if you can see the beam and the column and all of that, all of what goes into keeping the thing, the object, from collapsing, you've used technology, you've used that language, and that makes the building in an ideological way a progressive kind of building. The expression of technical language makes it so. But of course it doesn't.
I think we have this really brutal email exchange, which is like they're the shortest email exchanges ever. He sends 3 words and I send 5 back and vice versa. But I remember when we finished, the day that we finished the first iteration of the project, I sent you a picture of the final configuration and you replied back, I don't see the joints. And I replied back, that's the whole point. Meaning, there's a moment that...
That's not true. It's true. I mean, it seems to me when you present the project, when you publish the project, you only show the joints.
That's right. I mean,
And you could make an argument that if you took this and blew it up 1,000,000 times, that you wouldn't need any of this. This is actually the project. You could make an argument. So this is the building, and the mistake you make simply is it's the wrong scale. This is true. You could make that because it is that. It has that kind of presence. I it might be the interrelationship of this and all these pieces going in directions that you can't quite manage. It's not so much 45 degrees, you don't want 45 degrees, you want 42 3/4 degrees. You want something you can't measure, actually, not something you do measure. And again, I think that this is, to me, maybe I don't make it clear, that this is less measurable and quantifiable than a conventional building system, which is validated by claiming it's progressive in a technical way.
Just in order, the interesting thing is just like you were saying that this can become a building. I would actually say it can become a world instead of a building. And I think a world, a cosmos or a universe. But I'm not saying that arbitrarily. I'm actually kind of thinking about the drawings of Copernicus or Kepler, and kind of how they actually devise their own kind of geometrical imaginary of kind of what the world is about. I mean, when we were trying to figure out this geometry, a lot of the drawings, they look that way. So there was a certain kind of back and forth between those early drawings that they had to do with astronomy and a sense of geometry of like, how can you measure what's out there? And in this one, it's just like, it's a collapsed version of it, but it's just like there's a certain mapping of a possible world.
Let me ask you something else. This has to do with looking at a lot of contemporary architecture and over a period of time recognizing people and work who do certain things in a certain way. So it becomes a kind of point of view, and maybe over a period of time actually a style, a way of understanding the problem, whether it's in Guangzhou, whether it's in Cape Town, whether it's in Manhattan. And the question with a system like this is whether it, from your point of view, it leaves anything out. In other words, is this a mechanism that would qualify in a conceptual way to make any number of building types, organizations, strategies, and so on? Or is this just a piece of a much bigger picture, so there are a lot of elements that are missing here that would actually allow us to understand the applicability of the piece? Meaning, this is it, or this is one of
Well, I would say, like, going back to the idea of who's the enemy, I think that singularity, for singularity's sake, is the enemy. In terms of, I wish at least that the joint is universal enough that it can allow creativity to happen. I mean, just like from my side or from whoever.
Based on that argument, you wouldn't want a joint that was universal.
Well,
You might
no,
want
just
the opposite.
universal
Because
enough.
universal means generic applicability. And what we're talking about is applicability, but limited applicability, which means you have the next step is something else. What does it leave out?
It had, wasn't, I'm still, this is still in its infancy.
Well,
I mean, as far as.
because you refer to it as the
But
world
let
and Copernicus.
let me leave out. Yeah, that's right. Now, I mean, at least in the two different iterations, I mean, we try to show two very distinct things. I mean, the first one, in the first part of the project, we wanted to show kind of that the joint can work vertically, in a wall configuration, that it could work horizontally, in a cantilever configuration, and it can also negotiate the difference between one and the other. So it can be sort of like normalized on the one hand, and extraneous in the middle, and then normalized again at the end.
But why should that be the case, for instance? I mean, why couldn't the joint be 5 different sizes?
Because we wanted to. I mean, it's just I would say it as a compromise.
The size is really not the issue.
Well, it might be the issue if there's a compressive condition or a tensile condition or whatever it is.
I
The
see-
weight
I
changes,
see-
the height change.
I see it like as DNA in a way. There's a certain code within the joint that allows you to explore. I mean, and I think it's just like the more intelligence you can build within the joint itself, the broader the territory that you can look after. The moment you actually start having the joint A, B, C, and D, and A, which is always a possibility, I mean, like the more you face new problems, For example, I know that having developed these things, I know that there's another joint that has to be done that deals with other type of conditions that I couldn't sort out.
But see, I think all I'm saying is the intellectual way, there are two sides to the discussion. One is the versatility of the piece, which means it is applicable universal, which means it can fit in any number of situations. The other is the uniqueness of each piece, that each piece in both a consistent way and with some differentiation would be modified relative to specific circumstances. I mean, if this were spanning from Santa Monica to Boyle Heights, and it had to be, because this is interesting, we get to it at some point, what's the scale of this thing? You know, is the scale of this a homeless shelter? Is the scale of this a bridge to Brooklyn? Is the scale of this some kind of conceptual structure that crosses the city?
Well, there's definitely, I mean, let me jump on that one, because there's definitely a very interesting advantage of, it's like bringing the scale down. I mean, when you actually look at space frame applications there for talking about space frame, they're like huge large stands, and that's all you can do. Every time you actually try to kind of like scale it back to some kind of architectural condition that doesn't kind of have to do with infrastructure, I think that's kind of where the system actually loses its power. In this case, actually, we wanted to bring the possibility of working with space frames on a much smaller scale, and what I would call a more architectural scale, not necessarily an engineering one. So that was very important to kind of like try to achieve that. I mean, the mobility of the joint.
So the scale of the piece, so it's a one-to-one scale. So the scale of this piece is accurate in terms of your conception of the piece.
In terms of what it
But you could look at this. All I'm saying is you could look at this as a kind of superstructure, which has very different permutations in very different circumstances, but still belongs to an organizational idea, like a freeway or something, which has different manifestations as it goes up hills and over canyons and on.
Now that I remember, if the joint would be at this scale, 6 inches, I could have plotted 48 degrees. But then they look too big, then the whole thing, actually the more size you have, is a relationship between the joint and the screw or the fastener that you're using back to the strut. That's a ratio that governs the mobility of it. So
I think one of the issues that arises in all of these gallery projects has to do with what it is at what scale you're looking at. In other words, is this strictly a function of an object in a space with the limits of the space and budget and so on, which makes it what it is? Or is it illustrative of a different idea? So this is just a model at 1 to 100, but in fact the conceptual idea is very different, which would allow us to understand this in very different ways. That's all. Meaning, I live here, you live here, he lives there, and so on. We're looking at a city.
Yeah, well, what you're looking
And
at
at least that it could be suggested by something like this.
I think that's important. I think that's something that Brancusi specifically was brilliant about. I mean, like the way he actually produced his sculptures and the way he photographed them, they were very different. I mean, in a way, he tried to portray a certain meaning at the scale of making the object, but then when he kind of got back, I mean, the infinite column is infinite because the way he looked at it.
Sorry. Ideas have no scale, Eric. Scale is only when you apply an idea. I think that this joint, for me, is simply magic. So it's, I mean, there are different kinds of innovations, like the Lumiere brothers invented the film as a technical device to simulate speed. I mean, it's a trick, it was a trick. I mean, yes, made his first real film by painting it by hand. So there are different levels of innovation, and I think I give a shit about space frames. When I saw the first time they photographed that joint, as if they said, wow, that's magic.
Yeah, but this is like saying a shovel and a backhoe are the same. Well, dig holes. I mean, I think conceptually, this has a very different meaning if that's associated with a scale which is not the literal physical scale you're talking about. Whether you happen to like this personally or not, or whether the invention has to do with hitting a point from multiple angles that we couldn't do. That's an issue in a technical way.
It's geometric.
Yeah, the invention
It's geometric.
maybe, but in a human sense, it's also hypothetically purposeful. Means it is something, and its application into habitation, to the city, or to an art gallery means something very different depending on what it's applied to. This is a screwdriver. It's pretty. Who are we going to screw? And to what purpose? And this is a little bit that issue. In other words, the fact that this has intrinsic worth doesn't mean that's the end of the discussion. It's a piece of the discussion. And to repeat, if this is a scale model, it's different than this is the end, and this is the beginning, and this is the size. And I think it's suggestive of solutions to different kinds of problems if you understand it as bigger than it is or smaller than it is. That's all. I think this is part of the implication. This could be going across the Grand Canyon. It's about time we got a bridge going across the Grand Canyon. This is a way we might do that, or not. Yeah.
That one sounds good to me.
What else?
Was that a question?
Huh? It is.
No, one thing I think it's important to mention. I mean,
You could say, and this is a strong way to make a presentation. This is what I love. This is what I hate. This is the objective, or this is the intention, and this is how I'm delivering it. I mean, you described I think the title of this thing was Still Robots. Everybody we get into long discussions because people make labels that why is that the title of the project?
I think that the still part of the still robot is the part that might have been a little bit overstated.
According to the page.
Yeah, I just, in a way I would like to share a little bit of my idea of risk-taking when we do these things, because we're actually going to try a little bit too hard for my taste. The idea of ambition is just like, well, we can only do 10 feet, but no, let's go 20 and see what happens. There's a certain kind of sense of responsibility and something that we wanted to try, but there's a precedent that I always find inspiring, which is like the Wright brothers. I mean, for many reasons, but in a sense, I mean, like the first flight, it was actually only 6 inches off the floor for 15 seconds. That's kind of like the first time somebody kind of pulled something off the ground in an ideal way. And I think that's sort of something that we want those 6 seconds, those 6 inches, for whatever they're worth. And that's always embedded in the. I'm not make an apology of things falling down. I mean, it's not that we want things to fall down. I mean, it's actually quite the opposite. They did happen to fall down, absolutely. They did manage to collapse, but it's not something that we're kind of looking afterward. You can call it naivete if you want it, but that's something that I'm going to want to get,
Let me go back to something you said about risk. First, I mean, I think there's a sense in architecture, as it's understood in a radical way, that risk is intrinsic to that process. Is that true?
I wouldn't say so, but absolutely.
And the value in claiming to have taken a risk is what?
Well, that's actually personal.
Yeah.
Life
is personal.
No, but it's a personal in terms of like what's the idea of risk and what does. I mean, there's like a very, very thin line between risk and recklessness to a certain extent. So that's why that's sort of like a personal.
But really the question is there an intrinsic value in risk? Like I said, for instance, if you look at a lot of work over a long period of time that expresses technique and technology, ipso facto, you want to be a radical architect?
Okay.
GSD, 1972, maybe look like an oil rig, it's okay. Now you say, I took a risk, so everybody should say, great.
No. I mean, in this case, it's like the idea of risk it relates to how much we want to measure out of this project. It's not necessarily an idea of risk for risk's sake. We know that if we were actually going to like put the pieces on the wall, they would be stable. They will be here for the next 3 months, and we could close the door, and that's it. I don't know how much we would have done from that one. In the last 2 iterations that we kind of produced with this, and we kind of try to test different limits of what the project and the material and the joint can do, and what are the successes.
I don't think it has anything to do with risk at all in terms of labeling what you've done. I think it has to do with how you think ideas move and history moves, and whether things are known and can be repeated, or whether things are unknown and have to be discovered because in fact you don't have any other choice. And the options that's sitting in front of you is to say, I know, wall, floor, ceiling, window, or not.
I'm interested in that.
It's not a risk. I mean, what I'm saying is it's not a risk as an ideal, it's a necessity.
That's right, but
It's not a risk. It's like breathing.
A way that for me was always inspiring, just like this idea of change or evolution. It was most manifest in the copies of the medieval times, where they would actually have like a manuscript on the one side, and then there were unknown people, kind of like certain little key in some basement, copying one page to the other. What they were copying, they were modifying the content. Slowly but surely, I mean, like from copy to copy to copy, the content that actually reaches the 20th century is a succession of transformations from that original manuscript. Nobody knows who these people are. They've been there, I mean, just like, and nobody knows when the change happened and how it happened, but the content kind of continues to mutate and transform over time.
It's different, isn't it?
No,
I mean, I don't know that anyone sat out and who was transcribing medieval text and said it's unsatisfactory and therefore I'll adjust it.
Actually, it could be better.
Well, maybe it also has to do with one hand is never quite the same as another hand. I think what I'm getting at is whether it's fair for us to simply assign a category of risk which ipso facto validates the content of a project. Because the question is, it seems to me, leaves out something else, which is how to evaluate or how to understand what was changed, what was risked, what was learned, what moved. I wouldn't even say better or worse. I'm not sure things get better or worse, but they probably get different. And even this is an argument. There are people who are arguing that actually things don't get different. In a very fundamental way, they repeat themselves. So in the first place, if you're arguing for risk, you're at least intrinsically arguing that ideas change and they move. So what did we learn? What moved? What was advanced? And then you have a way at least to explain what was risk, as opposed to saying, I take risks, I'm a radical guy.
Let me maybe rephrase or define risk, first of all, which is like how much of an unknown quantity we want to deal with. I mean, it's not necessarily risk. I mean, that's why I think that's what I'm trying to say when I say the word risk. It's like how much of an unknown quantity we want to manage in the project, or we can build in, or we can try to deal with.
Well, we don't know what a conventional space frame is.
Well, but
many examples. We know what a conventionally designed universal joint is. We want to do something with that joint and with that assembly that heretofore couldn't be done in the definition of frame and the definition of joint. So you could say that. That isn't necessarily a risk. I think it's more like saying the linguistics or the language or the pro forma of the frame and the joint has a limit, because all of these systems are limited. You want the system to evolve in order to make it speak differently.
Yeah, but there's moments that on top of that, there's a threshold where you know that you're stepping in an unknown territory, and you know that's the moment of the project that, regardless of its possibilities, there's one more step that where things might or might not.
Let me say, let's see if it's an unknown territory or not. Don't you know when you see the space frame twisting across the room? Couldn't you have said when you started that that's where you wanted to end? And in that sense, the conclusion to the project was directed a priori, because you know what a conventional frame does. You know, a conventional frame can't do that. And what you were trying to do was to invent something that had a different visual, technical capacity. And you did that. So actually, it wasn't so much going in a direction you didn't know, but it was pushing the idea in a direction that you anticipated.
Yeah, in a way, it's like wanting to go to the moon. I mean, like, first of all, you have to have the desire to go to the moon, or the dream of wanting to go to the moon, and then you have to figure it out. You know, I was thinking this, okay, the guys that started working with rockets. And you say, like, the idea of going to the moon. How big is that rocket? Is it the size? Is it like 300 feet in diameter and, you know, 1,000 feet tall in order to reach there? Or what's the size of it? I think there's a serious investigation that kind of has to do with defining what the vehicle ends up being. But I think it's just like the vehicle cannot be without the dream of going to a faraway land.
I think what I'm saying, and maybe I'll use this example. Maybe this helps a little bit. If you, this has to do with a piece that I wrote for you the other day. If you say, this is English, this is the English language. To write a sentence in English, you say, this is a capital letter, this is a noun, this is a verb, this is a period. That's how you make a sentence. For a long time, lots and lots of relatively inventive and artful people, and others who were less so, wrote sentences like that. That's the language. That's how it works. And then somebody comes along like Faulkner or E.E. Cummings or James Joyce and says something different. That capital letter, noun, verb, and period don't allow me to say or to express or to experience a different way of communicating in the language. And at a certain point, it seems to me, all of these linguistic allegiances, whether they're in literature, whether they're in art forms, or whether they're in architecture, fall of their own weight. They do, because in the end, they don't work anymore. They just don't work anymore for any number of people. And in this case, particularly for very artful people, I mean, Joyce's work is still pretty radical work. It's 100 years old. 100 years old. So in this case, I think what I'm saying is there's a technical pro forma. There's an ideological image of architecture as it relates to an expression of technical capacity. And it resulted in a lot of projects that praised and acknowledged and so on. And we're still in that world. We didn't leave that world. There are people who want to leave the world. This is actually not going to the moon. I think it's still in a world we recognize and we understand. And we understand, I think, the problem that you're working on. So it exists in a certain context. I think you could argue that it's still a capital letter noun verb period. Well, it didn't dismiss the structure of the sentence. It amends it. I think this is actually what happened. And that's in a certain way because the conventional pro forma doesn't allow you to construct?
No, that's, I mean, we actually went through that process in the previous project that we did. I mean, this, in a way, it's not that one day we said, oh, the space frame joint or the ball joint is a big problem. But actually, in the previous, in the roof garden that we built a couple of years ago, we didn't have a space frame, but we had like a structural encounter that had to do with like many different angles coming into one point. And we're actually using standard elements, like standard framing elements. And the problem with it, it was pretty clumsy because like each one element would handle only one element at one strut at a time. So that meant that if you have one coming here, then the second one it was coming down. So just like you actually have like a difference between about like 9 inches between all of the struts in order for it to accommodate this one structural system that was. And having looked at that problem, it's just like that's what we're trying to figure out. Is that okay? These are the conventional means. These are the language that we're trying to convey. And there was a little bit of a slippage in between. And then we kind of started working on the problem of maybe how to resolve that punctuation.
But here's the other thing, which I think might go a little bit deeper. You know, there was, I used to have this cartoon, there was a film called Airplane. This is the name of the film, which I never saw. But we know what an airplane is: the tail, the wings, the engines, and so on. So the advertisement for the film Airplane took the plane and tied it in a knot, twisted it up and tied it in a knot. So the question is, I think it's an interesting question to me, why would you tie an airplane in a knot? Why would you do that? And the suggestion is, after a while, the conventional nomenclature of airplane is getting, we saw that, we flew in that, it's getting tedious. And I think there's another need, maybe it's a human need, to see it in a different way, to make it behave in a different way. And the transition from the conventional airplane, which belongs to aeronautics, in a technical sense, now wasn't good enough anymore. And the argument for architecture that belonged to, that obligated design in a technical sense, is not good enough anymore in an emotional sense. And you have to make it in a way to do something else because it needs to move in a psychotherapeutic way. We knew that, we learned that, we understood that. It's not an exploration anymore. Now, whether if you step back from that, whether the airplane tied in a knot is a childish manifestation of a transition, or whether it's a substantive manifestation of transition. So this maybe, meaning when is it adolescent, when is it silly, when is it change profound? But I think somehow what we're doing now is wrestling with that kind of movement in the language. It doesn't work, it's inadequate, whatever makes things tedious. Because one thing for sure, everybody is getting bored very quickly. Yeah? So this
I think that there's a range of interests, and it's, boredom is not just. I think it's maybe too general of a word. I still believe that people are not bored, they're hungry. It might look like that way, we might read about it that it's that way, but I still believe in hungry people, and I see them pretty much every day. So I wouldn't make a big word out of boredom. But I don't think just like that desire or that trying to overcome boredom is any more creative, or it doesn't kind of trigger any more impulse than.
I don't say that it is. It seems to me that's at least an aspect of the contemporary discussion, that it has to move automatically, because if you've seen it no longer holds your attention. Don't say that applies to everyone. Don't say that it's good, but I think I could make that argument in a qualitative way about the contemporary cultural situation. I think I could make that argument.
I think that problems evolve, and so have the means to resolve problems have to evolve as well. I mean, right now it's very strange, but in the last, any time that somebody calls to actually get a project, nobody calls and said, hey, can you guys make us a house? Can you guys make us a building, an office building? No, they asked and said hey, can you make a tent that to hold a 30-minute event. Okay, we can do that. Oh, we have this environmental problem. How do we resolve it? That's another problem. So it's no longer the problem of the architectural problem. It doesn't any longer can be resolved with a wall construction. In some cases it does, but sometimes the problem is just kind of like trigger other type of possible solutions where the means might be sufficient to resolve them.
I think what I'm saying, from my point of view, is topical for a student audience. So that a student audience that listens to lectures every Wednesday night and watches a very quick, it's not evolution in a Darwinian sense, it's evolution sometimes in a cataclysmic sense, jumps, big jumps, and trying to understand the cultural context in which those jumps take place and what engenders them, what pushes them, what we're looking for when we twist an airplane. Anyway, anybody else like to offer some corrections and additions? Omissions?
I think there was something really beautiful about the intent in the first opening where you said that it's only held out with 5 points, which I think gets you back to the Wright brothers, whose desire to hover, for those at least that are maybe gravity-based, also be something about keeping them up in the air. And I thought that was a really, I mean, if you ask them what's the enemy, it's the impulse to bring things down to the ground in a kind of resolved way.
It means gravity is the enemy.
I think the way he described it, because there was this kind of desire to have the thing in suspension in only 5 points, which in a space frame you could argue is essential or unessential.
This is sort of like it's more like a show of comment, but the entire surface area for load transfer of this structure and the previous one is the size of a penny. So you actually have like a punctual relationship between the plane of the screw and the surface of the sphere. If you add all those nominal dimensions together, which is like how the load is going from one stratum to the other, the whole size for the whole space frame is about this size. If you imagine like a welded joint, let's say a 3-inch wall joint, it's actually already 4 pennies for one joint.
Yeah, but it's simple.
So that's, I mean,
why is that an accomplishment?
it's an, it's not, I don't know if it's an accomplishment, it's an interest of mine.
Okay.
Because I think that there's a lot of potential still in friendship. A lot of potential to explore in kind of what you can do with friendship. And I'm saying this mainly for the 10 people that helped me in the last 20 days. And I think they're going to improve, I mean, this sort of a teacher relationship that roots that thing, but at the same time, it's just like there's a sense of friendship that can go very, 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 very far. So, and I kind of sincerely appreciate that. So that's why I think that there's a lot of room for improvement in the friendship department before we jump into the enemies.
I wonder, when I think about it, the only other person that I can imagine answering that the enemy is 41 degrees is Sisyphus. That is the enemy, the slope. And I wonder, as I'm sitting here thinking, Alexis isn't having to talk about the title of this damn thing enough. About the title of this project enough. But that, I realized going through it that the title is fantastic at this point. It's no longer a still and fixed robot, but a still and persistent robot that has to somehow develop a kind of a mechanics and poetics of persistence through some cycle of iteration. In that sense, had you not had to rebuild it, perhaps rebuild it again, there'd be a kind of perverse tragedy in that. And I wonder, to the degree that this does appear a more kind of Sisyphean and Herculean project at the end of the day, I keep coming back to a point they would have made that opened up a project for me that this is about that 125 points, how that array is governed, how it's connected, and the degree to which these points can actually hold that logic of constellation, how you make it perform. I hope you take me through a few more. But that's perhaps the most evil comment I can see.
Yeah, the difficulty with the title, not only your title, but Alexis's title with the robot has implications. You know, the doctor goes out of the room and the robot does the surgery or something. So, or you drop off your car, the mechanic goes around the corner for mojito and the robot fixes the car. And so it's suggestive, conceivably, it's suggestive of a process which, once it's organized and programmed, delivers just exactly what it's programmed to do, which doesn't seem to be what this is about at all. I mean, if you want to argue there are infinite possibilities in this mechanism, it would be very difficult to set up a robot to implement something like that. Robot means standardized.
I think the robot here is closer. I was thinking too throughout this, you mentioned the airplane, but the Matrix, the film Matrix, is a really over-easy kind of figure in this. But that notion of these points as I think this is an atmospheric project at a certain level, in which you reformulate and rearticulate those atmospheric potentials. I think is where it develops I think that for me is where the polemics lie.
But he doesn't talk about it that way. He talks about it there. He doesn't talk about it.
But Alexis talked. Everything about this has been about that node. And if it's about that node, and if it's about 125 in the space, I think it becomes about that, it becomes about a particular mathematics and how
But I think the point would be whether it's a means to do something. If you call it atmospheric, that's an so to make an atmosphere with a space frame, which is unrecognizable in terms of the conventional lexicon of space frames. So that's an atmosphere, let's say, which is less than precedent. Or whether it's the tool to make the atmosphere, but no particular atmosphere, no specific atmosphere, no single atmosphere that precludes other atmospheres that it could also make. It's the tool to make it. Now go make your atmosphere. Here's a screwdriver. This is maybe I didn't make it clear. It seems to me this is, in other words, have we invented a fascinating invention, a beautiful invention, an invention which could be the atmosphere. If you imagine this in the room and nothing else, the object qualifies as an atmosphere anyway. But that's not what you're saying.
I hope it is.
Well, in terms of constellations, we have to think about
Maybe she needs a microphone.
what? If you look at the idea of constellations across cultures, people are looking at the same stars. There's kind of magnitude, there's a hierarchy between them. Some of them are brighter and so on. But each culture actually identifies different figures within that fixed configuration. I think that's a little bit at least the dream of the aspiration of the project is just like the possibility of, within the same amount of points, that different cultures and different points of view can actually achieve different figures or different readings. Constellation.
Anyone else?
How about points of light?
Points of light?
That's a different one.
That's a different installation.
Anyway, I'd like to thank Alexis for one of the unique inventions, beautiful invention, which I think has given us a capacity. Maybe the reason we're having trouble with the discussion is we don't quite know what it can do, but I think we know it can do quite a number of fascinating things we didn't anticipate before we saw it. I think, as an aside, the question of working with people and working in teams, for anybody who's watched Alexis' process of work on projects with other architects and with students, I did say you have to have an enemy, but I also said you have to have a few friends, and you have to have both. And then maybe the proximity of the closeness of the friends has to do with how tough is the adversarial relationship with the enemy. Anyway, it's pretty clear Alexis excels at making friends and producing these projects with teams, and I think we can watch that. We watched it on a number of occasions. It's spectacular, and I look forward to more of that. So thanks very much for coming, and thanks to Alexis and his friends.